right, so today we're going to dive into section 4.4, which is about inequalities in two variables. If you look at your I can statements that are on the weekly schedule, it says I can graph solutions to linear inequalities in two variables. And I can represent constraints, which remember are like limitations. So I can represent constraints with inequalities and interpret solutions as viable or non-viable options in a modeling context. So we are trying to be able to make the graphs. We're also trying to be able to interpret solutions and non-solutions in a word problem. This is modeling context. So first thing we're going to do, just like we have for our solving systems, is we are going to remind ourselves of steps. So that way when we go to do this on our own, we remember kind of what our process is supposed to be. So step 1 of graphing a two-variable linear inequality is going to be to plot the points of the boundary line. So this is basically pretending like our inequality symbol is an equal sign and just doing the same thing we would do if this were an equation. Remember that you can do this by using y equals mx plus b. So plotting the y-intercept and then using rise over run. Or if it's in standard form, we could find both intercepts. Or we could make a table or t-chart. Any of these methods are valid methods for getting all the points for our boundary lines. So we are going to look at step 1 for try it number 1. And so first thing you're going to need to do is draw yourself a coordinate plane. I'm going to use a straight edge here to help make it more accurate. So here are my x and my y axes. And so I am going to count by ones and try to make them as evenly and nicely spaced as possible. All right, so that should do. I'm also going to color code these, so I'm going to move over to using red here for this example. So y is less than negative 3x plus 5. So first, we're pretending like it's an equals. This one is in slope-intercept form. So the fastest way to plot the points would be to say that b is 5. So that means 0, 5 is my y-intercept. So 1, 2, 3, 4, 5. Here's 0, 5. That's going to be my starting point. Then I can see that my m is negative 3. So that means that I have a rise over run of negative 3 over positive 1 or positive 3 over negative 1. So this means negative 3 over positive 1 would mean to move down 3, right 1. And then continue down 3, right 1. Down 3, right 1. It could also, if we wrote it this way, mean to move up 3 and left 1. Remember, you may not always have room to go the way you want. So you have to be able to move in both directions. So this is step one. I have plotted all of the actual points. So step two is to connect the points with a boundary line. Now, in this section, we are going to have two types of boundary lines. It is going to be a solid connected boundary line if your symbol is a greater than or equal to or a less than or equal to. It is going to be a dashed or dotted boundary line if it's a plain greater than or a plain less than. So in this case, this symbol is telling me that I should make my boundary line dashed. So I'm going to use a straight edge still, but instead of just connecting all the points with a solid line, I am going to connect my points with a dashed line. So this is very similar to what we did earlier this year with when we had open circles and closed circles on the number line. An open circle meant don't include that value. A dashed boundary line means don't include the points that are actually on the line. So now our final step is to shade according to the symbol. Now, a lot of times this is going to be intuitive. So if I say less than, and I want to look and say, okay, the values, the points where the values are less than this boundary line are generally going to be below. But sometimes it's hard to tell what is above and what is below. So if you can't tell above versus below, pick a point to plug in. If it gives you a true statement, shade that side. If it gives you a false statement, shade the other side. So here I might pick, let's say 0, 0. I can't pick something on the boundary line, right? That's not going to tell me anything. I'm picking something either above or below the line. So if I pick 0, 0 and I plug it in, that's going to give me 0 is less than negative 3 times 0 plus 5. So negative 3 times 0 is 0. 0 plus 5 is 5. 0 is less than 5. That's true, which means that my point, 0, 0, should be in the shaded region. In the Math Excel part of your homework, the way that you will shade is by choosing the paint can tool and then clicking on the correct side. Here, we're just obviously going to shade it in by hand. What this means, this is very important that you understand the meaning of an inequality. What this means is that every point on the shaded region is a solution. So this point, 1, 2, 3, 4, 5, negative 5, negative 3, if I plug that in for x and y, I should get a true statement. Anything that's in the unshaded region is not a solution and so should not work when I plug it in. When I look at part B here, the only change from A to B is the symbol. So we're not going to graph the whole thing again. But this is just from greater than to greater than or equal to means that this boundary line would be solid. Please write this down. Which means all points on the boundary line would be solutions. So if it is a dashed boundary, the points that we plotted in step 1 are not solutions. If it's a solid boundary line, like we would have in B, then they are solutions. So solid means points on the boundary line are solutions. All right, so now you know how to graph an inequality yourself. On number 2, the Science Club is selling t-shirts for $15 each and keychains for $5 each. Their goal is to meet or exceed $750 in sales. Will the Science Club meet their goal if they sell 30 t-shirts and 90 keychains? Explain in terms of the graph of the inequality, where X is number of t-shirts, so I'm labeling that axis, and Y is the number of keychains. So they've graphed it for you here. So the shading represents solutions. So everything shaded represents $750 or more in sales. So if we want to know, will they meet their goal if they sell 30 t-shirts and 90 keychains, I need to find that point on the graph. So 30 t-shirts would be right here with 90 keychains. This is counting by 40s. So 90 keychains would be like right there. So this guy here is 30, 90. And so, yes, they would meet their goal. And for the explanation, we would say because 30, 90 is in the shaded region. So anything in the shaded region or on a solid boundary line is a solution. All right, turn to page 89. Example 3 are a working backward. So they've given you the inequality and they want you to write what inequality it is. So we did this type of problem, except not with the shading or solid versus dashed, when we graphed lines in topic 2. So I need to know what my slope is, what my y-intercept is, and then what type of symbol I need. I see that this is a dashed boundary with shading below. So that tells me automatically dashed means it's either less than or greater than, no equals. Shading below tells me that it needs to be a less than. So I'm going to have y is less than. Now I just need the mx plus b part. So I'm going to count my rise and run here, rise 1, run 3. So 1/3, it's positive because it's going up. And the y-intercept is at 0. So y equals mx plus 0 is unnecessary. So I would just leave it this way. Last one that we're going to talk about here are our special types of lines, which we've already reviewed when we did section 4.1. But just to review again, when it is a plain X or Y only. Y equals a number are horizontal lines. X equals a number are vertical lines. So this -2, Y is -2 on a horizontal line here. I know that it's dashed because there's no equals. Greater than means above, and so I would shade right here. All right, this should give you all the basics to be able to try some problems on your own now.